So, welcome, and we will start looking at some other concepts which are very crucial to understand and use a battery. I have already defined what is called state of health, SoH. Second is state of charge and self discharge. What we like to understand that if you are given a battery, how do you estimate what is the state of health? How do you figure out what is state of charge? So, we are going to get into a little bit of detail, because this is crucial to actually design the battery and use it in electric vehicles or anywhere else. So, state of charge is just a percentage of total charge available at any particular time. It will keep on varying. State of charge of 70% means 70% battery is still there, 30% is full. So, many of you may have noticed that sometimes if you have a laptop, sign comes up, the sign says it is a 21 minutes, that is a 10% remaining. This is the state of charge. A laptop is estimating the state of charge and is displaying that. Now, if I look at how do I measure the state of charge, what is the mechanism? Now, open circuit voltage for a lead acid battery, not for a lithium ion battery, is a function of state of charge. So, I can measure what is called open circuit voltage. What is the open circuit voltage? When the battery is not being used, you get an open circuit voltage. When the current is 0 or nearly 0, you get an open circuit voltage, because if there is a certain current, the actual voltage will be less than the open circuit voltage. It is an open circuit voltage minus the internal resistance minus the current. So, the voltage at any point is OCV minus the internal resistance multiplied by the current. So, it will depend on the current. If the current is 0, you get the voltage as open circuit voltage. For a lead acid battery, it is linearly, state of charge is linearly proportional to open circuit voltage. So, just measure the open circuit voltage, you know the state of charge. And for a 12 volt battery, for example, open circuit voltage may vary from 11.7 volt, this is what is shown here, to 12.85 volt. 12.85 volt means it is 100%, nearly 100% state of charge, and 11.7 volt means it is 10% state of charge. For a 48 volt battery, similarly, a full battery may be 51.5, when it is close to 10%, it is 46.5 or 0. But this linearity relationship is not there. You can measure open circuit voltage, that is very important. If it is part of the battery, there will be a BMS which will measure the voltage, convert it into numbers and store it, or even can transmit it through a CAN interface that a battery may have. That will give you the voltage, but what will be the state of charge? For lithium ion battery, it is not linearly proportional. So, what is there for lithium ion battery? And this is a very important learning. Open circuit voltage or voltage versus state of charge. Voltage versus state of charge depends on, is different for charging and different for discharging. For example, during charging time, and it will depend on the amount of current. If I am charging at 0.2 C, then this is the curve. Now, this of course will depend on the kind of cells that you use and kind of battery that you use, but it is a typical curve like this. So, you can, when you design the battery, actually the designer will measure this, the voltage versus current. Now, you want open circuit voltage, so you want current to be negligible, very small during charging time, extremely low current, nearly 0 current. So, if there is nearly 0 current, this factor will be nearly 0. So, the voltage that you are going to measure is open circuit voltage, and that time you measure the voltage, and the relationship between the voltage and state of charge is given out here. So, if you look at it, when you are doing at 0.2 C, which is a very low rate of charging, the voltage will start at a very low voltage, will keep on increasing, and even you have come to close to 5% state of charge, and you are already the voltage is 3.5 volt. Now, it is going to increase somewhat linearly, not really linearly, it will go up. It will go up with 0.2 C, it will go up to 97% state of charge. So, nearly full, it is not full yet. This part of the curve, you actually try to charge it using what is called constant current. So, in the charger, the voltage is continuously varied. The voltage is applied, for example, in the beginning you may apply for a cell, if you are charging close to 3.5 volt, and you will find out what is the current. If the current is less than 0.2 C, you will increase the voltage slightly. If the current is more than 0.2 C, you decrease the voltage. So, you decrease voltage, and the charger can do that more or less automatically. So, that you track the voltage and you keep on charging. This is a constant current charging, in the sense the current is a fixed amount 0.2 C. So, depending on the size of the battery, you take 0.2 C and do this. This is what will happen to the cell voltage. When it reaches nearly 97% state of charge, then you will see very little, the voltage is almost constant between 97 to 100%. It is very close to 4.2, it may be 4.195, and now from 4.195 to 4.2, you do not want the voltage to ever exceed 4.2. So, you do not keep on charging with constant current, but you clamp the voltage, it is called constant voltage charging. This part is a constant voltage charging, this is a constant voltage charging, we will come to that, whereas this part is constant current charging. So, you do this at 0.2 C and you take this plot. So, this is the plot that will give you voltage versus state of charge, and you can use that, you can measure the voltage and then estimate what the state of charge is. If the rate of charge on the other hand increases to 0.5 C, you get a different curve. So, the curve is not, so depends on the rate of charge you are doing. So, then you get a curve like this. Your voltage is higher with for 50% current, because your open circuit voltage, if I look at it, if I go back to this, the voltage that you are measuring is open circuit voltage minus IR into the current. So, the current is larger, your actual voltage is going to be less than open circuit voltage. More the current, you will see the actual voltage has to be higher, actually the voltage has to be higher for the same SoC. Okay. Here for 0.5 C, this is for a specific cell, but you can take another cell. The trend is like this. You will see in this case it goes up to 90% and it reaches already it reaches 4.2 volt. Now you cannot charge it anymore. Well, you can charge, but you have to do what is called constant current charge. You keep the voltage fixed, the current will reduce smaller and smaller and smaller, and negligible current will actually flow. If on the other hand you charge at 1 C, you see the curve is like this, and it goes up to 80% and then it stops, and from here onwards you have to charge at a very low current to get there. If you do something like 2.5 C for the particular cell, you see that very quickly when the 5% state of charge is there itself, the voltage has reached close to 3.9 volt or 3.95 volt, and from here onwards it charges slowly, but it hits at 57% state of charge itself, it hits the top. So, you can 2.5 C is a fast charging. So, first important point that I want to make, fast charging does not charge the battery full, it can only charge in this case 57.6%. That is all that it will charge. For something, some other cell, you may be able to charge up to 70%, 75%. So, that will depend on cell to cell. So, this is what you can charge. This is the voltage versus SoC. Okay. Now, this is the charging side. What about discharging? Discharging also is a very peculiar curve, and these curves, well, manufacturers can give you a little bit, but actually if you design the battery, you measure it, you actually use that then in the battery. Now, if you look at it, if you discharge it slowly, let us say 0.2 C, your voltage will immediately increase at and so it is falling from here, it is falling from here with 100% charge, it will start falling like this, and by the time your state of charge goes to 10%, the voltage goes to 3.4 volt. On the other hand, at 1 C charging, it will go to, at 10% it will go to 3.2 volt, and something like 2.5 C charging, the only 10% state of charge is left at close to 2.9 volt. So, this, and if you see again here, said you can only very quickly it will fall to 3.6 volt if you try to discharge it at 2.5 C, and then it will charge. Now, these are extremely important when you design batteries. What do you do? So, your maximum amount of charge is actually located out here. If you see, fast charge cannot be done at over 57%. So, most of the measurements are done at using what is called open circuit voltage or nearly 0 current. Okay. So, these curves are important, how the relationship between state of charge and voltage. So, it is possible for you to measure state of charge at any time. If you want to take just a state of charge without talking about what is the state of charge is a reflection of how much the battery is charged, then the current has to be negligible. As soon as you start using higher current, you will see a state of charge showing a difference, that you will have to take into account, but in reality state of charge has to be always measured as if it is an open circuit. That will tell you the amount of energy that battery has at any particular time. Now, what is the implication of state of charge? As I told you, constant current charging at high rate can go up to only 57%. Beyond that is a constant voltage charging, which is a low current charging. Now, remember that high rate charging only meaningful for large battery. High rate charging also impacts the life of the battery badly. So, why? Because only 57% of the battery capacity is usable. If you take a 1 kilowatt hour battery and you charge it fast, only you get 570 watts maximum. So, you are really wasting most of the battery. So, but on the other hand, is 100 kilowatt, maybe 57 kilowatt is not bad. High rate of discharge also hurts the battery life. Now, again you see 1C charge discharge, it is something like this, 2C it is already becoming like this, 3C almost destroying the battery. Of course, there are batteries which can charge and discharge at 3C, but any 3C discharge will hurt the battery compared to low charging. Energy pumped into the cell between 3.5 and 4.2 when slow charged. That is what you see here. If pumping into cell is between 3.5 volt, close to this, to 4.2 volt. But for fast charge, it is between 3.9 and 4.2. So, the voltage is changing only very limited extent. Slow discharge, energy is between 3.4 and 4.1. SoC is not a linear function of voltage, and actual SoC is always the open circuit SoC. So, you charge or discharge at nearly 0 current, and that is what you take as open circuit voltage. And use that to calculate SoC. Anything else that you do, your SoC will not be accurate. So, this voltage method of state of charge, voltage versus SoC, is a very problematic thing. If you see, it is voltage versus SoC, it depends on whether you are charging, discharging, and the rate at which you are charging, discharging. So, voltage versus SoC method is not used in lithium ion batteries for estimating state of charge. We will come to what is used then for state of charge measurement.